Jai Hind students, today we will study about coordinate geometry, class 10, chapter 7. So we have already studied few things about coordinate geometry, how to plot on the graph in class 9. This time we will study about the algebra of coordinate geometry. Coordinate geometry was named in the honor of René Descartes. He is considered by many to be the father of modern philosophy. He was also an outstanding mathematician. So let's start. Our session objectives are distance formula, area of triangle, collinearity of 3 points, section formula. So let's start with distance formula. If we are being given 2 points with the coordinates x1, y1 and x2, y2, the distance between that is denoted by d. So how to calculate it? The coordinates, at the point P, the coordinates are x1, y1. So horizontal distance from y-axis is x1 and vertical distance from x-axis is y1. Similarly, at point Q, the horizontal distance from y-axis is x2 and vertical distance from x-axis is y2. So wherever these, let's take triangle PQN. When we draw a line through P parallel to x-axis and a line through Q parallel to y-axis intersecting at point N, we get right angle triangle PQN. So PQ square is equal to PN square plus QN square by our Pythagoras theorem. So let's see what will be PN and QN. PN is distance of horizontal distance x2 minus x1 and QN will be vertical distance y2 minus y1, as you can see that. So PQ square will be x2 minus x1 square plus y2 minus y1 square, and PQ is equal to under root of x2 minus x1 square plus y2 minus y1 square, which is our distance formula. Now let's see if we are measuring the distance of a point from origin. So our one point can be taken as xy and the coordinates of origin are 0, 0, and hence we get x minus 0 square plus y minus 0 whole square. Its whole under root gives us x square plus y square. Now let's see an example. We have to find distance between the points 3, 1 and 2, 4. So according to the formula x2 minus x1 whole square plus y2 minus y1 square, we have x2 as 2 and x1 as x2 as 2 minus 3 whole square plus 4 minus 1 whole square, and we get as minus 1 whole square plus 3 whole square, and 1 plus 9 is equal to under root of 10 units. So the distance between two given points is under root 10 units. Now let's take another example to see how we can use distance formula in various things. We have to check whether 5 minus 2, 6 minus 4 and 7 minus 2 are the vertices of an isosceles triangle or not. For this, we will take these points as A, B and C. We will calculate the length of AB, BC and AC with the help of distance formula to check the lengths, whether any of the two lengths are equal or not. So when we calculate AB, we get 5 minus 6 whole square plus minus 2 minus 4 whole square whole under root as square root 37. BC as 6 minus 7 whole square plus 4 plus 2 whole square again under root 37, and AC as 5 minus 7 whole square minus 2 whole square under root we get under root of 4 is equal to 2. So we see that the lengths of AB and BC are equal. So therefore, by the definition of triangles, triangle is isosceles triangle. Now let's move to section formula. In this class, we will only learn about internal division. So we have got 2 points A and B with the coordinates x1, y1 and x2, y2. Let P be another point xy which is dividing the line segment joining AB in the ratio m:n. So we suppose the coordinates of P as x and y. We join with various horizontal and vertical lines to see that triangle APH and PBK are similar. So as the triangles are similar, the corresponding lengths ratio will be same. So AP upon PP is equal to AH upon PK is equal to PH upon BK, and AP upon BP is M upon N, AH upon PK is X minus X1 upon X2 minus X is equal to Y minus Y1 upon Y2 minus Y. When we solve taking X part separately and Y part separately, we get X as mx2 plus nx1 upon m plus n is equal to my2 plus ny1 upon m plus n. Let's see how do we do. Rules to write down the coordinates of the point dividing a segment in the given ratio. So to divide the given points P1, x1, y2 and P2 with the coordinates x2, y2 in the ratio m1 is to m2, what do? We multiply m1 with x coordinate of P2 and we multiply m2 with the x coordinate of P1. So we cross multiply. And our step 2, we add the products obtained in step 1 and we divide the sum obtained in step 2 by m1 plus m2 and it is equal to x. So we get x coordinate of the point which is dividing the given line segment in the ratio m is to n. And then similarly we repeat these 3 steps to find out the coordinate of y. So we also find out the ratio of the point which divides the line segment joining the 2 given points. In this, if we have to find out the ratio, we take ratio as k is to 1 instead of taking m is to n or m1 is to m2. Because when we take k is to 1, we have only one variable and it is easy to calculate. Now we have got midpoint formula. We are saying that the point is dividing in the ratio m is to n. Now if the point is dividing equally the line segment, then it is called as midpoint and the ratio will be 1 is to 1. So when we replace m and n by 1, we get coordinates of point as x1 plus x2 upon 2 and y1 plus y2 upon 2. Let's move on to an example of section formula. We have find the coordinates of the point which divides the line segment joining the points 6 minus 2 and 9, 6 internally in the ratio 1 is to 3. So we write 5 minus 2 on the left hand side, 9, 6 on the right hand side and in between 1 is to 3 so that we can cross multiply. So x is m1 x2 plus m2 x1 upon m1 plus m2 which gives us 24 upon 4 is equal to 6 and y m1 y2 plus m2 y1 upon m1 plus m2 that gives us 0 upon 4 or 0. So hence the coordinates of the required points are 6, 0 dividing the line segment joining the given points in the ratio 1 is to 3. Now let's take an example to find out the ratio when we know the coordinates. So find out the ratio in which y-axis divides a line segment joining the points 5 minus 6 and minus 1 minus 4. Also find the point of intersection. So we take the ratio k is to 1 instead of m1 is to m2, so that we have got only one variable k. Now using section formula, we have got the coordinates as minus k plus 5 upon k plus 1 as x coordinate, minus 4k minus 6 upon k plus 1 as y coordinate. Now since that point lies on y-axis, that means abscissa or the x coordinate is 0. That means minus k plus 5 upon k plus 1 is equal to 0, or we get k is equal to 5. Hence we get ratio as 5 is to 1. Now putting this value of k as 5 in the y coordinate, minus 4k minus 6 upon k plus 1, we get as minus 13 upon 3. So point of intersection is 0 minus 13 upon 3. Now there is a point in the triangle centroid, which is the point of intersections of median of a triangle. The coordinate of this point can be calculated with the help of section formula. We all know that centroid divides the median in the ratio 2 is to 1. So first we take AD as the median on the line BC, and we find out the coordinates of D. Now since D is the midpoint of BC, we get coordinates of D as x2 plus x3 upon 2 and y2 plus y3 upon 2. Similarly, we get all the three coordinates of E, F and D. E is x1 plus x3 upon 2, y1 plus y3 upon 2, F is x1 plus x2 upon 2, y1 plus y2 upon 2. Now the point G is lying on the line segment AD, and AD, which is dividing the line AD in the ratio 2 is to 1. Applying this, we get the coordinates of G as x1 plus x2 plus x3 upon 3 and y2 plus y3, y1 plus y2 plus y3 upon 3. Now let's move to next point, area of triangle. So area of triangle, when you are being given 3 points A, B, C with the coordinates A as x1, y1, B as x2, y2 and C as x3, y3, we draw perpendicular lines and we see that we get two trapeziums, and to get the triangle's area, we divide it into three different trapeziums, A, B, F, E, B, C, G, F and A, C, G, E. So from the first two trapezium area, we subtract the area of third trapezium to get the area of triangle as half into modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. And let's see an example. We have to find the area of the triangle whose vertices are 1, minus 1, minus 4, 6 and minus 3, 5. So we take first coordinate as A, second as B and third as C. And using the formula, we get half into 1 into 6 plus 5 plus minus 4 into minus 5 plus 1 minus 3 into minus 1 minus 6. Solving this, we get the area of triangle as 24 square units. Let's see another example in which when we solve the area of the triangle, the value comes out to be negative. So find the area of triangle formed by the points A 5 2, B 4 7 and C minus 7 minus 4. When we put all these values in the formula, we get it as minus 4 upon 2 and equal to minus 2. But as it is an area cannot be negative, so we take it as 2 square units. So area of this triangle would be 2 square units. Let's move to next point, collinearity of 3 points. Now collinearity of 3 points can be checked by two methods. First method is distance formula. So we see that if there are 3 coordinates and we find out the length of using 2 at a time, length A, B and C, and if we are able to show that sum of any two lengths is equal to third length, then the points are collinear. So let's see an example. Use distance formula to verify the points A0, 7, B3 minus 5 and C minus 2, 15. So we first calculate the distance CB, which has come out to be 5 under root 17. Then we calculate distance CA, which is 2 under root 17, and then distance AB, which is 3 under root 17. So we see that the distance CA and AB, when we add them, it comes out to be equal to 2 root 17 plus 3 root 17 is equal to 5 root 17, which is equal to CB. Hence the points A, B and C are collinear. We have got another method to check out for the collinearity of 3 points, and that method is the area of triangle. If we are able to show that area of triangle is 0, that says that the lines are collinear, and it is the best method to check for collinearity. If we do not get area as 0, the points are non-collinear. If we get area of triangle as 0, then it is collinear. Let's see an example. Find the value of P for which the points minus 5, 1, 1P and 4 minus 2 are collinear. So we have put all the values in the formula of the triangle and we get P as minus 1. So let's have quick summary of whatever we have done today. We have calculated the distance between 2 points as Px1, y1 and Qx2, y2 as under root x2 minus x1 whole square plus y2 minus y1 whole square. Distance of a point from the origin is x2 square plus x square plus y square. The coordinates of the point Pxy, which divides the given line segment in the ratio m1y1, is m1x2 plus m2x1 upon m1 plus m2 and my m1y2 plus m2y1 upon m1 plus m2. Now the coordinates of the point which divides the line segment joining the points externally are m1x2 minus m2x1 upon m1 plus m2, m1y2 minus m2y1 upon m1 plus m2. And the midpoint of the line segment joining the points are x1 plus x2 upon 2 and y1 plus y2 upon 2. Area of triangle of the given 3 points is half x1 into y2 minus y3 plus x2, y3 minus y1 plus x3, y2 minus y1. And the 3 points are said to be collinear if the area of triangle is 0. Let's have a concept map, coordinate geometry. We study the related algebra to coordinate geometry, distance formula, section formula, area of the triangle. Distance formula is used to find distance between 2 points in a given plane. Section formula is used to find ratio in which point divides a line segment or the midpoint, or to find the midpoint of a line segment. Area of triangle is used to find area of triangle, and distance formula and area of triangle are together used to check for the condition for collinearity. Thank you, students.